Hi, what's up everyone? Today I'm gonna discuss a little project that I've been doing for the past few weeks. And the data that I'm using are mainly the manga texts and the anime faces. Recently I came across this literature, it's called the Chat Haruhi. So what it does is the chatbot or the chat GPT and other language models can cosplay, can quote unquote cosplay as a certain characters given that it has a profile, a background information, and a pool of dialogues. So given this, the chatbot can respond like Haruhi, it can act like Haruhi. And I was quite amazed the way how they collected the data set, and it's written in this, yeah, it's stated here. They extract the dialogue data from the TV scripts, or they can also extract from the novels. And all of it inspired me to do what I'm doing right now. So as I explained a while ago, in the study I'm using the manga text and the anime faces, and related to that, here are the agendas. How how do I task one is how do I detect the text or the utterance. The second task is how can I determine the speaker based on the text. And third, and not the least, what can I do by classifying facial expression? So starting from the task one, text detection. The tools I use is based on Ka White. So what does the OCR mean? It's the optical character recognition. It helps the computer to convert the image to the text representation. And what's amazing about this, it gets rid of the manual task. No need for human encoders, like if you want to extract the scripts. Okay. Here are the little examples I will show. Here I have the sample image of a girl. There are one, two, three, four lines of utterances. Speaker one, color yellow. Speaker two, color blue, and speaker one, followed by the narrations, represented by color white. When I feed this raw image to the OCR pre-trained model, but what happens is that it returns the text conversion or the converted text. And for those who cannot read Japanese, I would tell that it's 0% accuracy. Those texts do not get reflected here. And what is the solution that I propose? And what I did was, for example, let's say I want to display all the bounding boxes that the previous image, I mean the previous model generated. So there are plenty of bounding boxes. There are 8, and having all of this would result to inaccurate image to text conversion. What I did is to merge uh, nearby bounding boxes into one. Uh, what's the What's the result? Now I have the a simplified version. The goal is to make the bounding boxes as few as possible. As a result, what would be the image to text conversion results? Here, remember there are one, two, three, 4 lines. And ideally, I should have 4 lines of utterances. Here I have 5 lines. And at least 80% of the characters are accurate. In summary, the task one, it had before I applied the optimization algorithm, it had the less accuracy of text generation. And after I applied the merging boxes, what's correct? The merging bounding boxes, it resulted to the more accuracy, but more latency as well. So why is there a low latency? I mean, more latencies because the wait, yeah, the time complexity is O n raised to the cube. What does it mean? I'm using the nested loops, and in theory, if there are more images and more bounding boxes that is found in one single image, it would take so much time in order to complete the task. So that's the worst case scenario that you don't want to experience. And yeah, there's nothing I can do, but if there's a trade-off, I would prefer the more accuracy, even sacrificing the latencies. Anyway, second task. I'm done with this first task. For the second task, I want to recognize a speaker based on the text color. And my assumption is some visual novels, the text color can represent certain speakers. I can demo here. Here I have a one sample. The text color, based on the pixels, the background color, this dark brick color is the greater majority, super majority. We can omit that. We can remove that, and we have the bounding box color, which is green. We can also omit that. So what we are left is with the second candidate color, which is grayish yellow. So this can represent a certain speaker, and we can represent the certain speakers, and I think that's it. For example, in one image, if there are two different text colors, like what I've shown a while ago, like yellow and blue, if it's yellow, it would this text would be identified as a speaker one, belongs to speaker one, and if it's color blue, it would be assigned to the speaker two. So that's basically it. Then the task 3, this is the last part, and the most interesting part, fun part, I guess, is the classifying the expression, facial expression. What do I mean by classify expression? And how do I do that? Actually, I base my dataset. My dataset, I use this manga facial expression, contains a list of art manga faces that belong to 7 categories, and those categories are as follows: the angry, crying, embarrassed, happy, pleased, and sad, and shocked. It's kind of redundant to have the crying and sad as a separate entity, but let's see. And this is the Kaggle dataset. If you want, you can go visit it and train your model if you are curious. Anyway, interestingly, wait. Let me explain. Okay, for the training part, the training set consists of 300, at least 300 images, and training that, it would result maybe one epoch would be, how long did it take? Around 3 minutes, and total of 21 minutes training time. And for the F1 classification of the test result, I achieved 65% accuracy. So is that significant? Well, let's see. I also checked the other baseline models. Here, this one is baseline models 1 trained on the same dataset. It had 21% prediction result. Maybe this is accuracy. How about the another baseline? I prepared 2 baselines. Here it showed 32% accuracy. How about mine? I got 65% accuracy. God damn it. So I'm actually proud what the models that I selected. It's perfect. But in some emotion categories, it does not perform that well, especially the crying emotion. I mean, crying expression and the sad expression. The model is having a hard time distinguishing or finding a pattern related to these two expressions. Anyways, so after training the model, I can plug into the actual image. What does it mean? I could feed the actual image and check what's the facial expression of the anime face. Here I prepared 8. I created 8. Four images from the Dragon Ball. Who's this? Vegeta, Goku, and Frieza. And another 5 from the Rebuild World. And if you don't know, this anime would be on air, maybe on maybe in 2024 or 2025, one of the masterpieces that I've read so far. I would definitely recommend it. Anyway, I'm gonna try maybe 3 images so I could save time. Let's try here, Frieza. The process is quick. After feeding one image, it would already generate the result. So this image corresponds to the crying emotion. Well, is that true? I think it's anger because of this exclamation mark. But because this is based on the facial expression, well, we'll never know. And most likely this would be categorized as crying based on the data set that it's trained on. Maybe it's like this. Then how about I want to also try number 3. Number 2 is kind of obvious. 3. So the result is quick. Crying. Well, is that true? Well, the indication why it's classified as crying is because of this tear mark, I guess. And yeah, I think that's a big indicator why it was classified or categorized as crying. Next, I want to try 4, 6. Let's try 6 and 7. 4, 6. Let's try 4, 6. Here, wait, 4. So after feeding this image, what would be the resulting expression? It's shock. Well, I want to ask, do you think this is a shock expression? It could be, and I agree with the result. Then lastly, let's try the 6. Is this expression? Oh, embarrassed. Why is it embarrassed? Maybe because of this blushing and the shape of the eyebrows. Yeah, I think that's basically it. Uh, for the use cases of the project, the little project that I made, here are the 2 possible use cases. First is the auto tagging in the art websites. So if you're lazy, putting a manual tag, maybe the website can do it for you by using this kind of machine learning model. And another one is my um, uh, main uh, main task, which is dataset creation. And if I were to make a dataset, it would be shaped like this. Just to make things short, I can I can obtain the utterances, I can obtain the speaker, and I can obtain the expression based on the studies that I made. Yeah, I think that's it. So thanks for watching. I hope we can see you next time.